In this video, we will consider equation x cubed minus 28x equal minus 48. Such kind of equations are often suggested at mathematical Olympiads. The specific feature of this equation is that it is of the third degree, and such equations never considered at high schools. Why in this case they are suggested for Olympiads? The idea is that one of the roots of this equation is very simple, and the knowledge of this root can facilitate the general solution of this equation. In this video, we will consider the rule of thumb for solving equations of this type. As a first step, we will try to find integer root of this equation. We start with a simple number, let's say x equal 1, and plug in to the left-hand side. We will have such expression, which is equal to negative 27, and definitely it is not equal to negative 41, so this number is not a root of this equation. Let's take another number, x equal 2. Again, we plug into the left-hand side, make a simple calculations, and we see that we have here the number which is equal to the right-hand side. So x equal 2 is a root of this equation. Great. So let's rewrite this equation in this form. On the left-hand side, we have polynomial of third degree, and our goal is to factorize this polynomial if we know one of its roots. So the second step is to factorize this polynomial. To do this, we will use one of the theorem of algebra. According to this theorem, any polynomial, if we have at least one root, we can represent as x minus this root, in our case it is 2, times polynomial of degree which is smaller than degree of the initial polynomial by 1. So in our case it's polynomial of the second degree. This polynomial actually is the ratio of initial polynomial and x minus the root, in our case x minus 2. How to find this ratio? We will use a practical method which I will show you on this example. So we take initial polynomial and rewrite it in this form to have all degrees of x here. So I added 0 times x squared. This is just for convenience, it's not mandatory. Then we take this new polynomial and try to do as we divide the numbers. So we write here denominator, and then we compare the greatest degrees here and here, the terms with greatest degrees. Here it is third degree, here is 1 degree. So we compare these two terms, and we multiply x with something to have x cubed. So it is x squared. We multiply x with x squared, it will be x cubed. We write it here. We multiply negative 2 with x squared, we write it here. And then we subtract this, and we will have here 0 and here 2x squared. And then we take the rest of the polynomial, rewrite it here. Then again we compare x and 2x squared. To equate these two terms, we need to have here 2x. We multiply, we have here 2x squared minus 4x, subtract, and here we have 0, here is negative 24x. We rewrite 48 here at this place, and again we look to the first term here. We see that we need multiplier negative 24 to equate them. So we have here negative 24 plus 48. So we see that if we subtract bottom line from upper line, we will have 0. So this is the answer. So our polynomial is equal to this quadratic expression. And we can factorize our initial polynomial as x minus 2 times this polynomial of degree 2. Our next step is to find the remaining roots. We will use the result of factorization. So instead of this equation, we will consider another. We replace left-hand side with the product. The product is equal to 0 when one of the multiplier is equal to 0. In the first case, when x minus 2 equal to 0, we have x1 equal to. We already know this root. The two other roots we can find by equating this term to 0. So we have a quadratic equation. We know the formula to solve quadratic equation. I skip simple calculations, and we have two more roots. Second root is 4, and third root is negative 6. So finally, we have the following answer, that our equation has 3 roots shown here. You can substitute each of these roots to the equation and check whether the equation is satisfied or not. The result will be positive, so the problem is solved completely. If you like this video, you may want to click like button, leave a comment, and subscribe for the channel.